this session is about enterprise messaging with RabbitMQ. Who here has used RabbitMQ before? Ooh, nice. Very nice. All right, my name is Majano. I was born in El Salvador. I lived in the US since I was 16, and now I am a Malagueño since last year. So I'm living here for I don't know how many years until Europe is conquered. That's what I say. But I'm a computer engineer by trade. Hardware design was actually my passion, and I ended up doing software for some reason. And I also host the Modernize or Die podcast. You guys can subscribe. I put all the links and everything that's going to be available after my session, so you guys can actually download it as well. All right, so I represent a company called Ortus Solutions. We are mostly doing open source applications and software. We have over 350 libraries that we manage that are completely open source for developers. So our passion is to create tools for developers. All right, so what are we going to be seeing today? So we're going to discuss why you want to use messaging, what is messaging, different implementations. There's many different implementations for messaging, and of course, the AMQP protocol, which is what RabbitMQ is based on. So we're going to go in depth into that AMQP protocol and RabbitMQ. All right, I have a lot of demos. I've actually, for this demo, it's called Messaging Polyglot. You can find it here or in the QR code. Like I said, you can download it. I'll give you some time to take a picture. But I've created, I think, 6 consumers in 6 different languages and 3 producers in 3 different languages. This way you can have an idea of how to use the SDKs in different languages and how to actually make all these languages talk to each other in one single application. All right, so let's start on why we want to use messaging. So there are really 4 issues that are paramount, even though there could be many, many more. But the first 4 ones, I would say, is the first one, RPC, which is a remote procedure call. We're kind of used to that in the web, right? Monoliths, who here is working with software monoliths still? Okay, the lucky ones. Integrations, problem with integrations, right? We live in a day that we use many languages, right? For example, us at Ortus, we use even 5 different languages in applications. It really doesn't matter, right? Whatever language comes my way, that's what I'm going to use. Scalability, right? We're in the era that we no longer name our servers, right? If you're naming your servers still, you might have a problem, right? Servers are supposed to be volatile now, right? So that is the first kind of way to see things. So RPC is usually the best example to show you the problem. So let's say you have an object or a service and they need to talk to each other. Well, they start and they talk to each other, but they block, right? So one object calls the other one, it blocks, we wait. Once it's ready, we get the data back and we're done, right? The same thing goes with services. You know, you have an application that you're going to talk to a Twitter API or whatever API. The same story, right? You make a request, you're waiting for data, a lot of things can happen on the way, and then you finally can get your result if you get your result back, right? So there are issues with these approaches, right? It blocks the request, right? We're very tightly coupled, right? The sender really always knows about the receiver, and the receiver always knows about the sender, right? What if the call errors out? What if the call hangs? What if the receiver completely dies, right? So you have to be very proactive in order to work with these scenarios, and we are just used to it. So what about integrations? What if you need to integrate with many systems? Especially if you're doing in a financial institution that has many legacy systems, many different servers that you have to deal with, geolocated in different locations, many languages, right? What if one department is using ColdFusion? What if another department is using straight Java and another one is using PHP? How do you deal with that, right? How do we increase that decoupling between them? And what about federation, right? What if we just have to be in Spain and in the US and in Latin America, right? How do we actually make everybody talk the same language? And then scaling, right? Of course, now we can work with an X amount of servers. How do we notify all our servers in our cluster? What if you have a Kubernetes cluster or a Docker Swarm cluster with 100 elements? how do you notify all of them, right? How do you move different geolocations, right? How do you respond or react to these exceptions? And we get into the era of distribution, right? We are no longer in a single server, we're in multiple servers. How do we deal with that? So the goals are really simple in 3 areas. Asynchronous. That's going to be basically everything that we do is going to be asynchronous. We need to decouple instead of a tight coupling. Modularize, right? Whether we're using a hierarchical MVC framework or different microservices that we deploy. And then, of course, scaling and integrating, right? Different systems, different languages, different technologies, different external resources, right? So how do we achieve those goals? Is through enterprise messaging, okay? So enterprise messaging is going to provide you with asynchronous communication, right? That's the key. We don't want to wait for things. We want to just send them out and forget about it, okay? Many protocols, right? We want to talk to different things that are in the systems, many implementations, many languages, right? And of course, we can create different design patterns as well with messaging. And ultimately, it's referred to as event-driven programming, okay? So this is an asynchronous event-driven programming at a distributed level. Right, important. Messaging is a change, okay? It's sometimes referred to as a paradigm shift, right? It's really a fundamental change in how we architecture and how we approach these problems. If you've never done it before, for me, when I started with it, I was very confused. Right? I didn't know what happened. It's like, did I forget the message? How do I get it back? How do I respond? There were so many questions, right? But as you start going through the process, you start identifying, the benefits that come from not knowing, right? So that's important. So if you're a control freak, you need to let go. Let go. All right. This is sometimes referred to as an enterprise messaging bus. And it starts with a producer, okay? Who cares? It's a producer. And this producer is going to do things asynchronous. It doesn't care about the consumers, right? It can be any system. It can be any language. It does not get a response. This was the thing that was very hard for me. It's like, I don't get a response, then how do I get my data back, right? What do I do? Well, you're going to get another message, right? And then another message. So trust me, it'll get better. The producer then sends this message into the broker, right? This is called the messaging bus, or the broker. And then the broker is connected to different consumers, okay? So the consumers do not know about the producer, and the producer does not know about the consumers, okay? And again, this can be any system and any language, okay? So this is a topical view of what an enterprise messaging bus looks like. All right, so benefits. We have to get some benefits out of this, right? Apart from the frustrations that you're going to get with messaging, there are benefits, okay? So what are some benefits? All right, well, you are going to decouple. That's the number one thing, right? Your producers don't care, right? Your consumers don't care, right? That's important, right? Cross-platform technologies. This is the flexibility here. If you have a very large corporation and some teams are dealing with one language and the other one with other languages, this is going to be the glue that ties those languages together, okay? Event-driven programming. This is what's going to give you scalability, because you're not going to focus on a specific order. You're going to focus on the concept of an order, okay? So you're going to start thinking about abstractions as well, which is important. As software developers, we always want to deal with abstractions, right? We don't want to deal with concrete stuff. We want abstractions. And then you also can queue for later delivery. Right? I don't want to do this right now. Maybe I want to do this later, right? Maybe next week. And then we enter the world of asynchronous programming, okay, which in itself is a headache. Okay, whoever has done asynchronous programming, it's not easy. It gives you a lot of headaches. Load balancing, this is also important. This is mostly a side effect of benefit of these enterprise messaging bus workers. They give you already load balancing, okay? And we call them hulkified services, right? You're going to be very strong. So let's discuss the protocols that are going to make this happen. There are more protocols, but I'm going to touch on 3. JMS has been around for a long, long time. Java messaging systems, whoever did JMS, right? Okay, JMS. Then we have AMQP, which is an advanced messaging queuing protocol, which is our focus today. And then we have STOMP. And who here has heard of STOMP? Ooh, what is STOMP? You earned a hat. Go to the booth, I'll give you a hat for being honest. So STOMP is basically WebSockets. Okay, I don't know why they didn't call it just WebSocket, but they called it STOMP. So there you go. So STOMP are WebSockets, basically. Okay, and in the demos, we have WebSockets as well because Rabbit can actually talk STOMP. Okay, so AMQP, it's a protocol. It's something that is defined. You can go to amqp.org. It has a version on it, and there's many implementations of this messaging protocol. Okay, first of all, it is not JMS. So if you did JMS, forget about it. Turn it off. It's different. Okay. Standard binary protocol, like I said, it works on several different concepts that we're going to go through. I'm not going to go read them there, but it's been around for a long, long time. Very reliable, very secure. Many implementations from Rabbit to ActiveMQ, Cupid, StormMQ, and I'm pretty sure thousands of MQs that people have built. Rabbit, I would say, is one of the most famous ones. So Rabbit, what is Rabbit? So Rabbit is an AMQP implementation broker, but it can talk other protocols, okay? MQTT, HTTP, every TTP that you hear, it implements it, okay? And STOMP, of course, that we know now that it's WebSockets, okay? It's built on Erlang. Who here has programmed in Erlang? Nobody? You should check it out. Erlang is very weird. It actually allows you to execute functions from one server to the other like if it's a normal method. It's built for distributed programming. It's really funky. It's extremely fast because of that, reliable and secure. And like I said, there's tons of SDKs. And for example, us at Ortus, we manage the ColdFusion SDK. We are the ones that are officially maintaining it for RabbitMQ. And think of Rabbit as a post box, a post office, and a postman all in one. And we're going to start going through it. This is just left for documentation purposes. When you download the slides, I wanted to make sure that you guys have more information. So I'm going to skip that one. All right, so concepts. Okay, if we look at this diagram, and I learned through pictures. Okay, let's say we want to create a PDF, right? We start here with our web application, and it's a producer, right? It publishes a message that somebody wants a PDF, and the message includes metadata. And that's the important thing in Rabbit. It has metadata. The message not only has the actual body of the message, but it can have a header, it can have a routing key, a lot of more metadata information. It goes into an exchange that we're going to talk what it is, and then this is like the post office, right? So the exchange is the post office, and then it's in charge of routing that message to different post boxes, okay? Which can be the queues. And then, of course, we have our consumers that are going to be receiving from those queues, right? So in concepts, again, you have a producer, you have a consumer or more, right? You have a connection between the producer, right, and also the consumers with the actual exchange. You have different channels in that connection. The cool thing about Rabbit is that when you make a connection, let's say from a consumer to RabbitMQ, that's a TCP/IP connection, right? In other MQing servers, you have to create multiple connections. But with Rabbit, you don't. You can create different channels within your TCP/IP connection. That's called multiplexing. So it allows you very nicely to not use the system resources because creating TCP/IP sockets requires resources, right? It requires RAM, it requires CPU that has to be assigned specific to that TCP/IP connection, right? Plus the connection has to do the SSL handshakes if you're using SSL, et cetera. So it's a complicated thing. So Rabbit allows you to create virtual channels inside of the one connection. So that's really helpful because you can have 1,000 connections all within a single connection, okay? That's very different about RabbitMQ, architectural-wise, okay? And of course, you can identify yourself to Rabbit, so you can actually create different users. It has a very nice admin as well, so you can actually create different security patterns around RabbitMQ. Okay, more concepts. So we enter more diagrams. We have concepts now of queues, okay, that we see here. And queues are basically just a buffer that stores messages. That's it, okay? A message, of course, is going to be sent from a producer all the way back into the consumer. And remember, the consumer can also be a producer, okay? And a producer can also be a consumer, okay? Then the head really starts hurting, okay? Then we have the exchange, right? The exchange, like I said, this is the post office, and there's different type of exchanges that we're going to look at, okay? There's different ways to bind the exchanges to the queues, okay? And the routing key is essential as we're going to start navigating the different design patterns, okay? So these are the major concepts that you're going to be talking when you're leveraging something like RabbitMQ. Okay, so like I said, how it works, my mind works with big pictures. So when I did this, it helped me. Start off with the producer. Wow, we're going to create a message, but in this case, not only are we going to have the body of a message, which can be anything. It can be JSON, it can be binary, it can be whatever. We have a routing key, okay? It can also have headers, but let's focus on the simplest approach, which is body and routing key. And then that goes into the message broker or the exchange, right? And the exchange receives the body and the routing key, and it says, okay, what do I do with this, right? And it uses the routing key and identifies all the registered queues inside of Rabbit and says, okay, I need to deliver this message to this guy, and this guy, but not this guy, right? So the exchange can be very, very smart, okay? So those queues that we generate or we create, because these are created by us, right, developers, they are going to be bound to different types of exchanges, okay? So let's look at how to do that, right? So we have different usages and different patterns. So we're going to start off with the usages and patterns. So the direct messaging is the very simple approach where you put in a message, you use the routing key, and it goes to that queue, right? That's a simple approach to messaging. Now, you can also create work queues, okay? So this is another design pattern that you can do. So imagine if you had a service where you needed to be creating or image optimizations, right? And you don't want to be doing them inline synchronously, right? You want to do them asynchronously. And let's say that you get 5,000 images in one shot. How do you deal with that, right? Well, you can have many consumers, and you don't want that image to be processed by all of them. You want to be processed by one, right? So that's another design pattern, work queues. Another design pattern is publish and subscribe. And this is basically like JMS, okay? So it means that I put a message into the system and everybody's gonna get it at the same time, right? So can anybody think about another thing that we use almost every day that happens? Another use case? Just shout it out, don't be shy. You put a message in and everybody receives it at the same time. A WhatsApp group, right? Nice, or Twitter or whatever, right? Something that you publish and you want everybody to know immediately, right? That's a fan out. It's called publish, subscribe, or fan out. Another design pattern. And the other one is, I would say, the most complicated one, which is a topic pattern, okay? So referred to as usually routing or topics. It allows you to actually publish messages with different types of naming conventions. And then the exchange will be smart enough to direct that type of message with that specific topic or a fuzzy match on the topic to the different queues that can respond to it, okay? So those are kind of the different patterns. So to summarize, we can have direct messaging patterns, work queue patterns, pub subscribe, and different types of topics. All right, so to apply them, we need to talk to Rabbit, right? So Rabbit needs to know how to use these exchanges, right? Now, I'm just gonna look at 3 exchanges and not 4, because I believe there are 4 exchanges. What are the properties of these exchanges? Well, the exchanges have a name, okay? So you can give them a name. They can have durability, okay? And this is important. By default, they are not durable. That means that if there's a server restart or that RabbitMQ server goes down, all the data is gone, okay? Great for development, not for production, right? But it's only for the metadata and the settings, not the messages. Remember, exchanges have nothing to do but send messages. They don't hold the messages. Okay? And then you can also do auto-delete. This is nice for cleanup. You can say, hey, if nobody's using this exchange, just delete it. And that's great because when somebody comes in and uses the exchange again, it will be recreated, right? And usually you auto-delete for everything because they can be then lazy loaded and lazy brought back. Okay? All right, the first exchange is the direct exchange, okay? This is implementing the pattern of the direct message. So the routing is based on the routing key. The routing key is what identifies where this message goes. It's usually referred to as unicast routing, okay? It passes those messages to the queues that have those names. And I know you probably can't read it from the back, but they're there, right? And it's very easy. It's just the name, and it goes to the queue, right? And even Rabbit makes it super easy for you. They have what's called the pre-declared name, which is basically the default exchange. And the default exchange has no name. And all it is whatever routing key you give me, I'm going to match the queue. So if you have a key called stock.prices and you have a queue called stock.prices, that's where it goes. That's it. Very simple. So it tries to really help you in unicast routing very nicely. Okay? Now, the cool thing about also the direct exchange is that it provides load balancing automatically. So if you have 4,000 or 5,000 consumers, right, listening to stock.prices, right, the exchange is going to be smart enough and it will load balance between all of them. So you don't even have to do that, okay? You just publish your message and somebody that's listening is going to pick it up and work on it, okay? The other one is fan out. So if you guys used JMS before, this is very similar, okay? You send a message, and then all the queues that are bound to that exchange are going to receive that message. And we saw the example about a WhatsApp group or whatever type of approach. We've used it, for example, for real-time dashboards, right? We want to push. We created a project actually in El Salvador for a hospital, and outside of the emergency rooms, they had like TVs with the specific rooms, and every time there was somebody inside, we used Rabbit to push that room was occupied, right? And everybody in the hospital had access to those displays, so in real time they could see, okay, emergency room 1 and emergency room 2 are busy, right? Let's send this guy to emergency 3. So if you want real-time statistics and real-time dashboards, you can build it very easily with RabbitMQ. Distributed notifications is another one we've used. We used everything for deployment in containers, and we don't want to notify every single member of a container, right? So what we do is that we notify through Rabbit, and then all the containers that are alive can respond to that. So if we say, hey, we have a new deployment, we announce a new deployment, and everybody knows that there's a new deployment. So maybe they need to reset caches, or they need to remove certain things, etc. So you can use it for all kinds of great things, especially for mass communication. Okay. All right, topics. Like I said, this is the most kind of complicated one. It basically talks about the binding patterns, which are your keys, and they try to match against those queues. Not full regular expressions, which I don't even know why. They should have just done regular expressions, right? But they do partial regular expressions, okay? So you can say log period and a star, or log and a hash. There's many different kind of weird combinations that you can use with the topics, but it's not like JMS topics, okay? So remember, forget about JMS. But let's say that you produce a message called lazy.something, right? Or log.something, and then you have a queue that just listens to logs, right? You can send a message that says log.info, log.warn, log.error, et cetera, et cetera, et cetera. Okay. So that's the topic. It's basically for you to create different patterns and then bind those queues with those topics. And important to know a little bit more about these queues. Okay, what are these queues? So these queues, right, are the ones that are going to be storing your messages. They are using an algorithm called FIFO, which is first in, first out. They have a unique name, okay, so you can give them a name. A producer can create them, a consumer can create them, okay? It doesn't really matter from which end, right? But somebody has to create them, right? They have durability as well. By default, it is non-durable, so this is just pure in-memory. So if you have a failure in Rabbit, then of course you're gonna lose your messages and you don't want that, right? So make it durable, right? And they're gonna store not only in memory, but they're gonna store also in disk. So if you have a failure in Rabbit itself, then you can recover, okay? You can also say exclusive queues. These are a little bit tricky, and that it means that the queue is gonna be deleted as soon as the connection is closed. And only the party that declared that exclusive queue can talk to it. We mostly use them for secure purposes when we actually create dynamic queues that only my connection right now can talk to it, okay? So there are use cases for it that it gives you. And of course, you can always tag them to auto-delete. So if you want to do cleanups, you can. Mostly in production, we don't, right? For development, I do, right? Just to test things. Okay, what happens if the queue doesn't exist, right? What's going to happen with my software, right? But that's the concept of these queues, okay? First in, first out. The exchange will do the automatic balancing for you to do all that through the queue. That's the load balancing, okay? This is just part of it, so it really helps out. That worker queue, depending on how many consumer connections it has, it will determine that, and it will start sending things to it, right? It does round robin. There's no way for you to control the algorithm that I know of. It's basically very simplistic, right? There's no weights. There's no, detections. It just means that if you have a valid connection, it will connect it into that pool. That's it, okay? Now, the important thing about workers, if you're building workers, which is a great thing to build, is acknowledgements. So acknowledgements is very important, okay? By default, auto-acknowledging is actually turned on. So that means that when you receive a message, the consumer auto-acknowledges and says, hey, I received the message. Right? And that's okay, but if your message, imagine if this is a PDF that I need to create, right? I need to acknowledge once it's created, right? Not when I receive the request. So you have to turn auto-acknowledge false, right? And then your consumer has to be smart enough to process that specific request, and when it's done, right, when the PDF has been generated and let's say stored in S3, then you acknowledge your connection, okay? And that's important because if you don't acknowledge, right, then maybe this guy dies, right? And that PDF is lost, right? What happens then, right? Imagine if this is a money transaction. What if I'm transferring from bank A to bank B, right? I don't want to lose that money, right? I would be in big problems. So that's why you need to make sure that you acknowledge. Because if you don't acknowledge in a specific timeout, then the worker queue is going to say, you know what, you didn't give me the response in that amount of time. I'm going to send that message to another consumer, and they will send it, okay? So that's why it is important that these consumers, when they are receiving these messages, to acknowledge them, okay? This means, hey, I'm done. That thing is processed. The transfer is done. Go pick up another message and send it to another worker, okay? So acknowledgements are very, very important. All right, I'm gonna show you a lot of code, okay? Like I said, we manage the Rabbit SDK. You can find it in a software package manager we call ForgeBox. I know you can't really read it, but it's really easy to create producers, if you can actually see that. But even in our SDK, we've added the manage to do bulk batching, so you can actually batch messages as well. Very nice, very fluent, right? And to actually create consumers, you can create them in line with lambdas. So very easy, but I'll give you the code instead of these slides. I also wrote down how we've used RabbitMQ, because I think that was something that I needed at the beginning. I was like, okay, this is great, but how do I use it, right? So we wrote down several customer use cases. You can go through them. I'll go through them really quickly because I know our time is limited here. but there are, for example, this use case we created for a company in California, which was taking leads. So leads were coming up, and they were polling before. They were like every 5 seconds, they were trying to get the leads into the database. And now with Rabbit, we just push all the leads to even every person that's actually attaching them, right? So they're what they're called their customer sales agents, right? In this case, we had real-time changes that needed to go to different systems. One was built in ColdFusion. The other one was actually built in another version of ColdFusion. Another one was in Ionic. And everything was just published through fan out. And that was great because everybody knew what was going on. So that was a great use case to use. This one we used STOMP. So we used the WebSockets approach to push messages to the sales team. So once somebody actually is on the website, a sales worker gets notified and says, hey, there's somebody on the website on this page, right? And they can track them, right, like a stalker, and basically take them through what they're looking at, right, and stuff like that. And when they spend too much time on it and they click the help, then they can help immediately because they have been notified already, right? So a lot of that. We also use the authentication plugin. This is when you start getting more advanced with Rabbit. You can actually, through WebSockets, connect to the HTTP auth plugin, which basically is just a REST call. And Rabbit can very nicely connect through JSON Web Tokens and say, hey, I've received this request. Are they secured, or can I talk to them, right? And then Rabbit itself can talk to a specific API. In this case, we created a REST API using Callbox. This is the framework that we created. And it says, here's the WebSocket, the web token. Is it valid? Is it who they are? And then it gives a response, and then they can connect through WebSockets. So you can do many even advanced patterns with Rabbit if you want to deal with security through WebSockets, because remember, WebSockets, any browser can connect to that specific server. Okay. We also created real-time chats with Twilio and SMS. So we receive messages from Twilio, and they're pushed to different phones as well. So you can do a lot with Rabbit. I'm going to skip it. But there, try to put as much as I could there of things that we've done to give examples or inspirations for you. I'll take you through the demo code that I've written. We have about 10 minutes. But like I said, it's all here. If you want to take the last picture there, and then I'll put everything in SlideShare, and then we can look at some code. Right. Before we start, any questions? No? You're mesmerized by the rabbit? All right, this looks tiny. Go big. Is that okay? Better? All right, so this is the RabbitMQ dashboard. It's really cool. You can do a lot through the admin dashboard. This is a plugin, actually. And you can see how many nodes, because with Rabbit, you can federate it. So that means that you can create a cluster of Rabbit. I can also tell you that probably in production in about 6 years, I've never had one of these die. And, I just said that, and now it died, right? But I've never had a RabbitMQ server die on me, ever. They're really, really solid. Okay? It gives you all the information about your connections as well, so you can see the different connections, the different multiplexed channels that are here, your exchanges. This is the cool thing. You can see the default exchange. You can see that they give you even some, like a direct, fan-out, headers, match. So they try to help out and give you these exchanges already created for you by default. You can even add a new exchange here. So if you wanted to create the OpenSouthCode exchange, which is a direct exchange with durability and no auto-delete, that's it. I created my own exchange without coding, right? I can go into that exchange, and you can see the messages. You can look at the bindings. See, there's no bindings to any queue, but if it's basically a direct, you can say OpenSouthCode. And that's the queue, and the routing key will be OpenSouthCode, and then I bind it, right? And, I haven't created the queue, but I'll create the queue later, right? So you can queue the queue right here. So I can create a new queue right here, OpenSouthCode, there. Now I can create the binding. Let's go here, OpenSouthCode. So anything with OpenSouthCode, then I can bind, see? So it allows you to do a lot of testing, right? I think there was a link I put called RabbitMQ. Oh. Let me see if I put it in the README. I'll look for the example, but I believe there was an online tester. Do I have it here? Rabbit. I'll look for it. But there's a way that you can test all these things out online as well. And you can see the messages flow from the producers to the consumers. I'll look for it because I forgot where I did it. But anyways, that's the administrator. So in the code, and that looks super tiny. Let's go big. I'll give you how this is architected, and then we can look at some of the code and then run it and see if everything works. I have a Docker compose, which basically just creates, that's so huge. It creates a Rabbit service. It gives me my secret passwords here and just leverages the ports, and I tell it which modules or which plugins I want enabled, which in my case I want the admin, the visualizer, STOMP, and web STOMP so I can do WebSockets, right? And once I run that Docker compose, right, it looks like that. It starts, right, and now I can interact with Rabbit, okay? A producer, so let's look at a producer. Okay, I have two folders, a consumer and a producer. Okay, the producer, I have a CFML one, which is a web application, so that's a CFML engine. Command box, this is our CLI tool, so this is basically just using the operating system and the CLI. And I have a Java one, so you can look at all the different types of producers in different languages. This is the command box one. I leverage a produce, and I leverage a price generator. A price generator is just a class that basically creates stock symbols. And then here's my producer, which looks so huge. There you go. And in my producer, what I do is basically I class load the Java classes, and then I say, hey, I want to create a connection. Here's my username and password. Give me that connection and create now a communication channel. And then I'm going to create my price generator, and I declare the queue right here. So I'm going to declare a queue with that name, stock.prices, right? And then when this task gets executed, it just goes forever, right? And actually it goes until 100 messages. So I'm going to produce 100 messages. And all it does is talks to that channel, and it says, channel, I want you to publish into the default direct exchange, right? So the routing key will go to that queue. So stock.prices will go to stock.prices and send the price, right? So imagine this is how they do the dashboards in the New York exchange, right? They use messaging. So they produce the prices, and the prices are being pushed everywhere, right? And there you go. So this one sleeps, and that's it. That's all it produces, okay? Then in consumers, I went a little crazy here, and I created a web application with CFML. That's the CFML one. Command box one, again, through the CLI, so I can look at the CLI. I have a Groovy one, so I've created a Groovy consumer. I've created a Java consumer as well. I've also created a Node consumer, and I've created a STOMP consumer, which basically is a pure HTML and JavaScript WebSocket, okay? So lots of stuff here. So we'll see if it breaks. Okay, oh, let's look at one consumer. All right, let's look at this guy, worker push. There's different types of APIs you can implement with Rabbit. You can use a stream API, or you can use a polling API. The polling API is a lot easier. It looks like this. It basically, as you can see here, it does the same thing that the producer, right? It creates a connection to Rabbit, it creates a channel, and it declares the actual queue again, just in case, right? And then it basically says to the channel, hey, I want a basic get. That means that this will block right here, and it will wait until it receives a message, okay? So you can see here that it says, hey, I'm going to talk to that queue, right? And it waits. Once it receives a response, it processes the response, okay? That's the very simple one. The worker push basically is creating a little bit more sophisticated one, which instead of doing a basic get, I've actually created a class called consumer, which looks like this, consumer, which has different methods on it, different callbacks. Handle at cancel okay, handle at consume okay, handle the delivery, etc. So it basically reacts to different events instead of just blocking. Okay. All right. So let's see if it works. All right. Many things here. So let's see if I can get everything working. All right. I'm going to put on this left corner right here. Where am I? Okay, I'm on the messaging polyglot. I'm going to go to the producer, command box, and let's see if I can produce a customer here. So I'll say task, run, produce. All right, there you go. So it's producing messages, right? And you can see here stock.prices showed up in the admin, and you can see all the messages coming in, right? So now I'm able to produce those messages, right? It's going to produce 100 and then stop. So I'm in the consumer section right here. So I'm going to try to consume something. Task, run, worker. I'm going to use the push one. And that's going to be receiving, and it's received all the messages, right? But then I left it running, and I'm going to look at the Java one. And I try to run the Java one. So now I have a Java consumer. I have a CFML consumer. Let's get Groovy with Groovy and run the Groovy consumer. Okay, we'll leave that one running. Okay, I don't know if I can do this. Can I do that? Yes. All right, and let's do Node. All right, so Node worker. All right, 1, 2, 3, 4 different languages. Okay, running right now. So let's see if they actually work. Cross your fingers. And there you go. Now it's load balancing between all the 4 languages, the messages that I'm producing. Okay? So you can see that it's a lot not fast because it's actually load balancing between all of them, right? So while that runs, let's go start a web server. Whoa. All right, so I'm going to start a server right here with command box, with just an HTML server. Okay. Okay, the messages stopped and all the queues stopped, and then we're going to add another component here. So this is just going to create a little web server right here. Yes. All right, so now let's do WebSockets as well. Let's get even more complicated here. Get out of the way. No. Right. So we have now here the WebSocket using an HTML application. We have the 4 different languages, and then we're going to be producing, and now we have everything pushing and load balancing between all of them. See? So very easily I have my WebSockets with my HTML application. I have all the different languages going, all the different systems that could be reacting to these stock prices using the direct messages. And that's the power that you can get with RabbitMQ, right? Once you know how to connect, right? All right, so this way you can look at the code, you can see how it's done in all these different languages. They're all pretty much the same, but the idea and the power of doing this, right? And connecting all these different languages and different systems so you can communicate, okay? So with that, thankfully the demo didn't crash. So if you have 5 minutes for questions, I have 5 minutes for questions. Wait. Thank you. Yeah, had a question?
Yes, thank you. Thank you for the presentation, by the way. It was great. I was thinking how we could handle multi-tenancy with RabbitMQ. If you could explain, I don't know, a pattern or so that we could use to handle when we need full isolation between the tenants?
Yeah, I think that you would basically go back to, I'll go here, right here, the routing key. So the routing key would be the one. So if you want to target only a specific tenant, you have to tell it which tenant, right? So you could even create a queue specifically for a tenant, right?
Right, and how could you handle like costs when you want to segregate costs for would you say that if I need that level of isolation, would I need a different instance, for example, or a different?
No, I can honestly tell you that even for that client in California, which is the largest one, they have one instance, and we haven't even had a need to cluster it. We just have a standby one for redundancy, but like I said, because it's using multiplexing, it doesn't consume a lot of resources, right? So it will mostly be, depending on the amount of messages that you receive, is when you start separating instances out. But I haven't even reached that limit right now. Yeah.
Great. Another question, how would you handle observability? And if you need, for example, to see the events flowing like you showed here, would you say I would just put a topic for observability, or is there another tool that I could use?
Yeah, I think that the RabbitMQ admin really has everything you need, right? I think that, I don't even know where I went now. No! I forgot the port too. There we go. So the RabbitMQ administrator really has everything. So the managers, the DevOps guys are always looking at it. They're looking at the connections. They're looking at the channels, right? Everything. I mean, they have probably like almost 2 million visitors a day for their websites, and we create one single queue even for a visitor, and it manages because they auto-delete. So once they're done, it auto-deletes and it scales back. So I would say the admin is the best place. Yeah.
Great, thank you. Thank you.
More questions? No? All right, well, thank you so much. Enjoy the conference, appreciate it. And we're in the booth over there if you want to hang out or get a nice ninja hat. We'll give you a nice ninja hat. Well, thank you.